here we have an infinite sum from 1 all the way up to infinity of the square root of n minus twice of the square root of n plus 1 plus the square root of n plus 2. So first I'm going to use the finite sum, then let n approach infinity. So in other words, my infinite sum from 1 all the way up to infinity is in fact the finite sum k from 1 to n, then take the limit, n approaches infinity. It's the same effect, right? So first of all, my finite sum k from 1 all the way up to n of square root of k minus twice of square root of k plus 1 plus square root of k plus 2 is equal to the sum from 1 all the way up to n of square root of k minus twice of the sum k from, notice this time I'm going to rewrite square root of k plus 1 into square root of k. I am allowed to do that because k, remember, is just a dummy index. It just indicates where we start and where we end, right? So since we start from 1, so meaning inside the square root we start from 2, right? So we start from 2. Again, we end at n, so inside the square root we end at n plus 1. That's all it means, nothing more, right? So likewise, my last sum is the sum of square root of k. Again, we start from 1, meaning we start from 3 inside the square root. We end at n, so we end at n plus 2 inside the square root. Right, if I rewrite into k, square root of k. So, for the first sum, I'm going to rewrite it into partial sum. First of all, partial sum. Notice that the first item of this sum is just start from 3, so therefore I have to write it partial sum starting from 3 as well. And I want to end at n, right? Because this sum and that sum already included n, right? They go beyond that, right? So square root of k, right? Partial sum separately, right? Meaning I have to write my first and second item separately. So first item, that is just 1. Second item, square root of 2. Right? So likewise, minus twice of, first of all, partial sum, I want to start from 3. Right? I want to start from 3. I want to end at n as well, of square root of k, which means I still have my first item and my last item. Right, first item is k equal to 2. That is square root of 2. My last item is what? Plus square root of n plus 1. Right? So my last sum, again, I want to start from 3. And I want to end at n, right, because it goes beyond n, square root of k, separately. Right? What's my last 2 items? Last 2 items is square root of n plus 1 and square root of n plus 2, obviously. Now, this time, my finite sum, okay, from 1 to n is in fact really equal to, I can obviously cancel out the majority of the terms, right? Because I already have square root of k all the way through inside the sums, right? I have exactly the same index, exactly the same number of terms starting from 3, ending at n, right? They can just cancel out. This sum and this sum, exactly the same sum, twice of them, right? I have minus twice of the same sum. Right, so these sums, they can just cancel out. And I'm left with just 1 plus square root of 2 minus twice of square root of 2 minus twice of square root of n plus 1 plus square root of n plus 1 and plus square root of n plus 2. Right? So I actually have 1 minus square root of 2 plus square root of n plus 2 minus square root of n plus 1. Now, let's just look at this expression. This expression obviously approaches 0. Why? Right, just simply ignore the 2 and 1, just square root of n squared minus square root of n, right? Simply just, but we still have to prove it rigorously. Okay? Just multiply by its conjugate on both the top and bottom, right? Meaning we just change negative sign to plus, right? So on the bottom, we actually have square root of n plus 2 plus square root of n plus 1, right? What's on the top? So this multiplied by its conjugate, we have this item raised to the power of 2 minus this item raised to the power of 2, right? We actually don't have square roots anymore. We just have n plus 2 minus quantity of n plus 1. Right? N cancel out. 2 minus 1, 1. Right, as n approaches infinity, this whole fraction obviously approaches 0. Because the bottom obviously approaches infinity. Right? So, this approaches 0. In other words, my infinite sum, right? As I let n approaches infinity, my infinite sum is really equal to 1 minus square root of 2. Is my final result.